6 log base 3 of 7. Better stop worrying about plus, minus, times. All right, so all the exponents first. And then you're left to right multiplying, okay? If you're subtracting here, you couldn't do more than 2 at a time. But because I'm adding, which means multiply, I can just do them all at one time. So log base 3, don't rewrite the log. When you condense, you should only have log one time. 7 to the 6th times 2 to the 6th times 5 to the 12th. Now, looking over some of your classwork, if you are multiplying two things together, okay, if they have the same base, you can add the exponents, okay? But if they have the same exponent, let's say I have 3 to the 2nd times 5 to the 2nd, I combine the base, but I leave the exponents alone, so this is 15 to the 2nd. But if this was 3 to the 4th times 5 to the 2nd, I can't just do 15 to the 6th. It doesn't work like that. On y'all's classwork, a lot of you did this. You had different bases and different exponents, and you just combined both. You can't do that. That doesn't work. No. Yeah, you can leave it like. You could, for this one, since these exponents are the same, you could combine those two if you wanted to 14 to the 6th, 15 to the 12th. I wouldn't multiply that out because that's a huge number. I'd leave it like that. But if you want to, you could. Like 14 to the 6th power times 15 to the 12th power, yeah.
So I don't have to.
Oh, it should be, I'm sorry, it should be 5. Yeah, it's going to be huge. Have to what? That is solved. It's not, you're not solving, you're just condensing. Condensed means it's written down and there's logs only written one time. If you want to, you could. Yeah, it'd be huge. It'd be huge. Yeah, you could do it. Either way's right. I'm listening.
So everything is
Okay.
I had that one.
Log 2 of 11. Log base 2 of 11. 4 of them? That. So dividing by 3 is the same thing as multiplying by a third. So really all of these have a number in front of 1/3, right? This is 1/3 log base 2 12 plus 1/3 log base 2 7. This is not even a log thing. This is just a algebra thing. We will, yeah, I will. Now, because these are numbers in front, I'm going to come around as an exponent. I keep right, this should be a 2, right? Now I multiply. log base 2 of 12 to the 1/3 times 7 to the 1/3 times 11 to the 1/3 times 5 to the 1/3. Because they all have the same exponent, I can put all those bases together. So 12 times 7 times 11 times 5 to the 1/3. Yeah, you're condensing. So your goal is to get it down to just 1. Right. And I don't know what that is. What's 12 times 7 times 11 times 5? Carter? Use the calculator in front of you, bro. You want it? 4,620. If you had it as a third root, that's fine too. You could, or log base 2 of the cube root of 4620. Does it have a cube root? Is it a perfect cube? I'm guessing not. Yeah, you can make it any. Yeah, there you go. Put the root. So if it's 5, put 5 and then go math 5. Other questions? 2 log base 7. What? What are you saying? Oh, you like the letter U. Okay. Y'all could understand that. I'm actually glad you asked about this one, Carter, because this one's all subtraction instead of all multiplication. I mean, all addition. All right. All right, so I've got U7. And this one would be a 4x prime. Oh! I see what you're saying, sorry. Now, when you're doing subtraction, it's division, right? You only want to do 2 at a time. Don't do more than 2 at a time and go left to right. So I'm going to do these 2 first. And I'm going to say this is log 7 of u squared over w squared. And I've still got this one off to the side. Are y'all okay there? Now, I know that I need to divide this by this. Do you agree? What is u squared over w squared divided by v to the 4th? No. Instead of dividing by a fraction, multiply by its reciprocal so you don't get confused on if it should be in the numerator or the denominator. Okay? So this is going to be log base 7 of u squared over w squared v to the 4th. I could also have rewritten this. This could have been in the beginning, and it would be the same thing. That's why it's multiplied in the bottom. Is that what you did? I would say get it down to a fraction, a single fraction, instead of a complex fraction. This is a complex fraction is a fraction in a fraction. We did those. Yeah, we did them. Remember we had top, bottom together? Leah, do you have a question? Like that? Did you? I'm going to change each one of these to a half times log base 9 of u. No, I'm just trying to do it so you see where I'm getting these values from, what's happening. So now when I bring them over as an exponent of 1/2, and I think I'll do these together. I'm going to go ahead and put those together. So log base 9 of wx plus log 9 square root u plus log 9 square root v. If you left it as an exponent of 1/2, that is okay too. I have log 9 wx plus log 9 uv. And now because those bases are the same, I can multiply those together also. So log 9 wx root uv. Did you? Yeah, that's fine. This will be a 5. Yep, it'll be a 5 right now. B. I'm going to do the exponents first. Log a to the 5th plus log c to the 5th minus log b. Oops. Now divide. Now, if you want to put those two together with the same exponent of 5, you can. You don't have to. You got to go order of operations. So, but they are the same thing, but that's why we do this, because addition subtraction is left to right, whichever comes first. So you always have to do the first two first and then go to the next. I just couldn't figure out where that was coming from at first. Yes, no, maybe so. Anything else? Yes. E to the whatever equals it, yeah. But you'd put this in your calculator. E is irrational, it'd be, yeah. Lucy, you asked for an expansion. Give me one. Where's the 2? Stop saying that. Nobody had the same ones. You might have one similar. but it was not the same. Because I'm expanding, I'm going to split this cube root up just to show you what happens here. So you can see the different. I'm just going backwards of the order that I condensed in. So now I'm going to split the multiplication up. I'm going to have log base 3 of 7 plus log base 3 cube root 5 plus log base 7 cube root 2. Cube roots, oh gosh. Cube roots are nothing more than exponents of 1/3, right? Yeah. So it'd be log base 3 of 7 plus 1/3 log base 3 of 5 plus 1/3 log base 3 of 2. And you're done. You're done. Thank you, James. I appreciate the support. All right, let's review graphing exponentials, number 1. This is going to hopefully kind of nice like this. What? So these are kind of inverses of each other, but you'll see that in just a minute on what it is. All right. I only have 11 in AP Calculus. Wonderful. All right, let's look at the first one. 3 to the x minus 2 plus 1. Tell me what you know. Tell me what you know. Up, what's up 1? Well, everything's a graph. So where's the asymptote? At 1, right? Is it growth or decay? How do you know? The base is bigger than 1, so it's growth. Right 2, that's exactly right. So a normal one would cross, well, let's just plug in a couple points, I guess. Let's plug in 1. No, let's plug in 2. 2, 2. 1, 2, 1, 2. Plug in 1 more, maybe 3. 3, 4. So there we go. Domain? That's right. Range? I do too. We'll just keep on going. Range is 1 to infinity. We said y-intercept. How do you find y-intercept? Plug in 0 for which one? For x, that's right. So 3 to the 0 minus 2 plus 1, which would be 1/9 plus 1, which is 1 1/9, 10/9, 1.1. So there's my y-intercept. It asks you for the asymptote. Looking over some of your quizzes in classwork, a lot of you are just putting the number of the asymptote, but make sure you put the equation, because if it's horizontal, it's y equals. If it's vertical, it's x equals, right? So what is the asymptote here? Y equals positive 1, right? Because that's a horizontal asymptote there at 1. How about increasing intervals? Negative infinity to infinity. How about decreasing? None. It never decreases. In behavior, which is where y'all have started to flounder a little bit for some reason. Okay. It's not just you. Increasing is as you move left to right. Is the function going up or is it going down? It's going up, so it's always increasing. It's not, no, it's not ever decreasing. In behavior, yes, this is exponential versus logarithmic. We've already done exponential, but I'm going to show you how it ties into logarithmic. That's why we're graphing this one first. Decided. What? No, we just went through graphing all that. The asymptote and plugged in the points like we did before. You're supposed to. The limit. Noah, you watching? As x approaches infinity of f of x equals, it's kind of like, yes, it's kind of between, equals infinity. Yes. I don't know, yours was funky. Good, we do this every day in calculus. I did not.
No, I just thought everybody was beside me.
No, I thought it was limit, you don't pick it as.
One. It's approaching the asymptote. While you were on your extra long brain break. What are you asking me? I picked 2 points to plug in here that would be easy to plug in. 2 was easy because that'd give me an exponent of 0. 3 was easy because that would give me an exponent of 1. Right. Plus 1.
How do you plug in the points today?
Well, then why did you say,
Wait, 2 minus 2 is 0.
But it should be 1.
Y'all, look. 3 to the 0 power is 1. What is 1 plus 1? Here's the equation. Look at your sheet. There's the equation. It's 3 to the x minus 2 plus 1. I didn't plug in 0. I plugged in 2. I first plugged in 2, and then I plugged in 3. Everybody with me now? I says everybody with me now? All right, that is the exponential. Now let's do the logarithmic, and there's a reason that they are both written for number 1, but I'm going to walk you through what happens here. Everything with logs are opposite of exponentials, okay, because logs and exponentials are inverses of each other, okay? Remember graphically what an inverse looks like. It switches x and y, okay? So essentially this is going to be a logarithmic graph over on the side. Carter, do you need me to wait on you a second? Yes, logs are like turned on their side. They're exponentials turned on their side. 10 over 9. Plug in 0 for x. Y'all are like my kids at home. You try not to laugh because it encourages the behavior, but what was that for? Nothing. It was nothing. Okay. What? All right, can we go to the logs now? Is everybody with us? Same page. Everybody good? On. Oh, y'all remind me to mark me absent. She's not here. Notice what the base is here. And we're graphing right beside the other function. They had a base of 3. The bases are the same thing. All right, here's what you need to know. I don't think I'm even gonna waste time showing you the parent graph and transforming it, this and that and other. I think the easiest thing with logs is to look and just tell you this number inside is your vertical asymptote this time, opposite sign just like before. So it'd be a positive 1, that's exactly right. And outside of that, we're just going to pick points to plug in. We're going to pick 2 points to use to plug in and see which way it hugs the asymptote. Okay, so let me show you what I'm talking about. The positive 1. Where was the asymptote on the exponential? This one This is why it's important. I said don't just write equals 1. This time it's x equals 1. On the exponential, it was y equals 1, right? We need to be clear in where our asymptote is happening. Now here's the part where you're probably going to get a little. It's hard to evaluate a log, do you agree? Sometimes, right? So here's what I want to do. I want to think about some numbers that are going to be easy to evaluate. So I'm going to think about these two properties that we talked about yesterday. One of them being log base b of b is always what? 1, right? So if I could make this be the same value as this, it would be easy to evaluate. Do you agree? And the other property I'm going to kind of think about is the log base of 1 is always 0. So then if I could also cause this one to be 1, it would be easy to evaluate. Do you agree? So I'm going to pick two x's that are going to cause that situation to happen. And I'm pretty sure we did this in algebra 2, but I can't remember. I got to it one semester, but not the second semester, or not the other.
Well, we had a
I had two different, did we? Okay, maybe I'm thinking last year before then. Okay, I don't remember if we got to this or not. Sometimes we get to this and sometimes we don't. And I don't remember if we did or not. So if we didn't, it's okay. So my two x values that I'm going to pick, and they don't have to be this, y'all, but if you just plug in, say, 10 here, it's or maybe 9 or 8, whatever it is, it gets hard to evaluate, right? But if I pick, okay, what did y'all say? If I want these to be the same, 4, that's not hooked to the log. What I want x minus 1 to equal 3, and then I want x minus 1 to equal 1. So I'm going to let x equal 4, and I'm going to let x equal 2. Those are going to be my 2 points I'm going to use. What happens when you plug that in? Watch. For the first one, the log base 3, 4 minus 1, plus 2. Log base 3 of 3, which is what I wanted, right? I wanted that because what's the log base 3 of 3? 1. What is 1 plus 2? So this point on this graph is 4, 3. 1, 2, 3, 4. 1, 2, 3. No, they're not. Yes. 4, 3. I plugged in 4, I got 3 back out. Now if I plug in 2, log base 3, 2 minus 1. What's 2 minus 1? What is log base 3 of... Yes. So 2, 2. 1, 2, 1, 2. There's only one way to go with the graph. It hugs the asymptote. Think about the exponential just on its side. It hugs the asymptote in only one direction, so it's got to be this direction, and this is going to be the one that comes up. Yep. Does that make sense? It's easy. The hardest part is figuring the points to pick. But you notice the difference in how they look. If you took every point on the other and you inverted the x and the y, you'd have the log. Yes. So I used x's that would make x minus 1 be 3 and make x minus 1 be 1, because what I want is I want one scenario where the bases are the same, and I want another scenario where the value there in parentheses is 1. If you do that every time, it will make it so much easier on yourself. But you don't have to do that if you want to use your calculator and find some points. Sure. Well, but your calculator, remember, is a base 10. So if I wanted to graph this on my calculator, I'd have to do log x minus 1 divided by log 3 plus 2. I'd have to do change of base. Yes, no, maybe so. What's the oh. What's the domain? What's the range? What do we have next? X-intercept. How do you find an x-intercept? That's y-intercept. This is x-intercept. Make it equal to 0 for the x-intercept. Well, if I make it equal to 0, how the heck do I solve that? Just solve it. Just solve it. That's what you said. Just solve it. Subtract the 2. But good job, Jackson. Put it in the other form. 3 to the negative 2 equals x minus 1. Ooh, this is starting to look familiar. How did that happen? Remember? How did that happen? You gotta do the E. That's right. You gotta do the E. Okay, so the E only works when the log's written first. That's why I moved it around for you. The base is 3. 3. Logs always equal exponents. And this is what's left to equal x minus 1. So 3 to the second power equals x minus 1.
Oh, yeah, it's over.
Yeah. As long as you've got the log isolated, meaning just the log by itself, you can always change the form if you need to. Yeah. Where would you have an exponent in that? To the 10th? I would need to, and then I would divide both sides by 10 and then change the form. He was asking, oh, you mean it's just changing forms? No. No, we're.
It's not like the. It's just like. It's like the sunshine. Yeah, it's like the sunshine.
Yeah. It's one of those jokes, Mac. One of those jokes. That is correct. Yes. We just digressed. All right, so this is 3 to the negative 2 is 1 over 3 squared, which is 1/9. And I add 1 to both sides. So my x-intercept happens to be the same thing that my y-intercept was on the inverse. Isn't that convenient? If it's the complete inverse of it, this happened to be. Oh, yep. All right, we did domain, we did range, we did x-intercept. How about asymptote? Oh, we did asymptote. How about increasing intervals? Oh, yep, you're right. Why is it 1? Left to right. How about decreasing intervals? None. Bless you. End behavior. As x, all right, the limit as x goes to infinity, this side's easy, of f of x is what? Infinity. What's the other end look like? The limit as x approaches 1. That's exactly right. And I'm actually going to add a little something here because it's not as x goes to 1 both ways. It's only coming in from the right side. Do you see that? I'm going to add a little plus here to say it's coming in from the positive side of 1. This is something we're going to talk a little bit more about as we get further into this. But if you're talking about x approaching 1, x could approach 1 from this way. What if this was my graph? Then it's approaching 1 from the left. So I'm going to say it's approaching 1 from the right, from the positive side of 1. And what does it get closer to? What does it approach? Negative. It's definitely negative infinity. So this little, that says from a positive side. That was only one problem. So e's are a little bit different because for e's, we're not picking these specific values. We're going to use our calculator to let it help us on e's. So if you graph a natural log, flip over to number 4. I'm going to skip the e and I'm going to go straight into the log one because that's the new stuff. Huh?
Yeah.
What do you mean, how would you do it? Number 3, the 1/3 log base 2.
You put the 1/3.
No, you can leave it like that. You can leave it there. I'll show you. That one, it's actually not that bad. They're reciprocals. I mean, they're inverses of each other, yes. Okay. Okay, so let's talk about what we see here and what's going on, okay? Knowing what I know about function transformations, what is this negative sign in here? Reflected over which axis? Y. It's reflected over Y. So now, when I have this vertical asymptote, instead of being over here on this side, it's going to be over here on this side. Does that make sense? Why? Okay. This means this negative in front is going to mean that it's a reflect over Y. The negative in front flips it up and down, but the negative in front of just X flips it left and right. Right? Huh? Okay. All right. These are easier to graph on your calculator because you don't need to change a base because you have an LN button. It is right under the log button on your calculator. So I'm okay with you using that and with you using the table on that for the logs to find these values because they're going to be nasty little decimals that are just going to be irrational and go on forever. But everything else still stands true. Where is my asymptote on this graph? It's the number that's being added or subtracted within the log. Look at this one, right? It was -1. This one's just log -4x. So I could do +0 there if I wanted to. So 0 is the asymptote. There's no left or right shift on this one. Do y'all see that? Going from log x to log of -4x, I haven't shifted it left or right. I've horizontally shrunk it and I've reflected, but I haven't shifted any. So my asymptote has remained where it is. Y'all okay with that? All right. So my asymptote is still at x or y? X equals 0 is my vertical asymptote. Indeed it is. Logs have vertical asymptotes. Exponentials have horizontal asymptotes. E is exponential, natural log is logarithmic. Logs have vertical asymptotes. All logs have vertical asymptotes. All right, what I would do if this was me is I would take out my calculator and I'd hit y equals log negative 4x. Yes. You can see the graph of it, but what I would do, go into your table, second graph, pick a couple points that are easy enough for you to graph. I'm thinking maybe second graph, 4.386. For which one? Why are there errors? If my graph does this, how am I going to find a value when x equals 1? It looks like that, but you can't. There's no graph there. That's why it's an error on your table. There's no graph there. Okay, so -2, maybe I picked that one up. -2, 5.079. And I'm going to use those two to graph. I don't know. I'm sure you look to see. All right, -1, 1, 2, 3, 4 point. I'm going to go by twos maybe. Bless you. 2, 4. And then -2, 2, 4, 5. So that it's coming in to hug my asymptote. This way it doesn't actually cross. I'm sorry. Does that make sense? We're not making this any harder than it has to be. We're going to let the calculators, we'll let the calculators do the heavy lifting on natural logs. Domain. Good job. Rain? That's right. X-intercept. That's a problem. Is that what you said? That's a problem? X-intercept means to put a 0 in for what? Okay. How do I solve that? And then change the form. When I change this, what does it look like? E. Logs always equal exponents. Whatever the log equals, that's your exponent. Now take out your calculator and do e to the -3 divided by -4. Yep. Increasing intervals. Decreasing intervals. What are in the, in behavior. The limit. As x approaches, you said negative infinity? Equals what?
Oh, yeah, I know.
Infinity. Why? Why, Robert? It's going up. On the left end, it's going up. We saved the harder end for last. Now I need to do this end of the graph. So it's going to 0, but this time It's going from the good job. It's going from the minus side. It's coming in from the negative side of x. What does it equal? What do y'all think? Graphing log. That's not true? That is kind of true. Solve for x. I'm just doing the x-intercept because that's what you said you start on. If you're caught up and you're good and you do not need any more help, the first page is classwork, the second page is homework. So 1 through 5 before you leave, and then 6 through 8. Yeah, let's do 6 through 8 before you leave. Give me the back page before you leave. You do the front page for homework. That'll give you 3 since you got 20 minutes, 25 minutes. You 3 to do in 20 minutes, but then the 1 through 5 will be homework. There'll be 5 for homework and 3 for classwork. I think that's fair. So she can come, yeah. Just rip them apart. Make sure you put your name on the second one so I get it. I had you a classwork assignment, but we obviously don't have time. That's okay. What's your name? No, you gotta be right. Even if it's not necessary. Okay, so if I solve this for x, first thing I need to do is what? Plus 1, because you have to find the x-intercepts, and the x-intercepts are found by plugging in a 0 for y. Before I can solve this, I need to get the log completely by itself, so now what do I need to do? Move the 1/3. How do I move the 1/3? Y'all are way overthinking this. You probably did, but great day, you did a lot more work. Change the form. 2 to the third equals x plus 4. What's 2 to the third? 8. 8 minus 4 is... What did you do? You made it a third root, and then you changed the form? So you did log base 2, third root, x plus 4, and then you changed the form. 2 to the first. Raise both sides to the third power. You knew it was 2. X-intercept. Yeah. It's probably 6 through 8. So just rip it. Just stay black.